If you look out into the night sky, what do you see? Depending on where you are, you might see the night sky as this, like that, or even like that. Nah, I'm joking. Something like this. But why is it so different everywhere? Aren't we looking at the same patch of sky everywhere on Earth? Well, the answer is pretty sad. Imagine if you were living in the year 1900. It's the beginning of the 20th century. Now, looking out into the night sky, you would see this beautiful galaxy. So many stars that your eyes can't even comprehend the amount of stars they can see. But now let's switch to the current year, 2025. If you're watching from the future, hello. Now it's possible that you can't even see a single star. And all that because we want safer streets. Yes, I'm talking about the street lamps and every artificial light source. You might think the street lamps and city lights don't really affect our night sky, but you should realize how sensitive the night sky is to light pollution. And especially how faint space objects are. Light needs to travel many light years, maybe even hundreds of light years, thousands, maybe even millions of light years from the other side of our universe. Now let's look mathematically how faint stars are. You maybe know the inverse square law. If you don't, let Chuck McGill explain it to you.
Intensity drops off with distance per the inverse square law.
Okay, whoa, inverse square, I'm not a physicist. Could you dumb that down a shade for me?
The farther away it is, the stronger the source needs to be to have an effect.
So to give you an idea how faint the inverse square law makes stars be, we will look at Aldebaran. Aldebaran is a pretty bright star and it's pretty close to us, at around 67 light years. Now looking at the inverse square law, you can see that the intensity of the light drops off with light over the distance squared. So as you can see in the graphic here, after just 4 meters, the light quantity is just 6.25%. If we applied it over 67 light years, the percentage is gonna look quite small. The percentage is roughly 2.65 times 10 to the power of minus 34. Now turning it into a normal number, it will look like this. This is such a comically small number that it makes winning the lottery pale in comparison. In fact, you could win the lottery every single week for billions of years, and the odds of that happening are still dwarfed by the ridiculously low odds of photons coming from Aldebaran to our eyes. And you could imagine how the other stars pale in comparison to that if Aldebaran is a pretty bright star and it's very close to our sun. So just imagine all the stars in the universe, and most of them are very far away and most of them are pretty dim. So we would receive even less light from them than from Aldebaran, where you could win the lottery every week for billions of years. That's how faint our night sky is. And now you would see, with the ridiculously small amount of photons reaching our Earth, that every small light source has an effect in interfering with those photons. And the thing is, the photons don't just vanish or something, but these artificial light sources make the sky brighter, and because of that, the tiny amount of light coming from the stars is even more invisible than it already is, and they are drowning in artificial light. And now the thing is, if we suddenly had a power outage, we would instantly see the entire night sky in its full glory. Because this pollution isn't like plastic in the ocean or something, but it's light, it's instant. So if we turned off every single light, we would see the entire night sky in its full glory. There are stories of blackouts in cities, where people left their homes and didn't understand what they saw in the night sky. They thought it was some weird cloud. Some people called the police because they thought that aliens were coming to invade us. But after all, it was just the beautiful night sky which they never saw in their entire life. Me personally, I also never saw the night sky in its full glory. The closest I've come to it was Portal Scale 3 in Austria. But realistically, what could we do about it? Maybe we can't just turn off every single light. Well, the most important thing is the light wasted.
What the fuck is this piece of shit?
Light shouldn't be directed at the sky, but on the road, for example. And the best protection against light pollution is when the light is hooked up to a motion sensor. I mean, let's turn off the light when nobody uses it. Unused light makes up most of the light pollution. Also, I saw a video about a street lamp that's shown horizontally instead of vertically in New Zealand, which was specifically designed to prevent light pollution. Thanks for watching. Change the world.